Hello everyone, how are you all? Welcome to the class. Students, in our previous video we had discussed about the distance time graph in uniform speed, and today we are here to study about the distance time graph in non-uniform speed. That means when speed is changed. So you are seeing here that here if non-uniform speed will be there, then this graph will be curved. Okay, now since due to the time increases, the distance that will also vary, so the graph will not be straight line. Okay, you are seeing in this figure. Now distance time graph when object is stationary, that means when object is not moving. So after traveling a certain distance, when a moving object it stops moving or become stationary, then the distance which is traveled by it does not change with time. Students, it remains the same or constant. That means the distance time graph for an object which is not in motion, that is which is stationary, that is straight line parallel to the time. Here you are saying that speed is 0, that means it is stationary. Okay, now how to draw distance time graph? Students, understand with help of an example. You know that the distance that is written in kilometers 1 to 5 and 0 is also, and the time 0 to 5 minutes. So here whenever you will draw the distance time graph, so what conclusion do you get about the motion of the car which is moving? So here in solution we will take here the graph paper and draw a horizontal line that is x-axis and a vertical line that is y-axis. Okay, and write time in minutes on x-axis, so you will mention here time, and on y-axis what will you mention? Distance. Okay, in this problem we are only small, here we have small time value 0 to 5 minutes. Okay, to represent, so scale we used for showing time can be 1 minute is equal to 1 centimeter. Okay, so when you mark it here, you are seeing that this one is indicating the time in minutes and this one is to the distance in kilometers. So here when you mark it, the value of 0, 1, 2, 3, 4 you are seeing like this. Okay, so this one is the distance time graph for a sample problem 1 which is given here. Now here next one is in figure 2.16, that means which is given here 2.16. again the distance value given in this problem, that is 0 to 5 kilometer. So the scale to be used for representing distance value on graph, that is 1 kilometer is equal to 1 centimeter here. Then we know mark of distance value, that is 0 to 5 on y line. Okay, so that is OY. Okay, the first reading given in the problem, that is time is equal to 0 and distance is equal to 0 at initial position. Okay, so at the time is increases, that distance is also increases, and you will find graph like this. Okay, now students, next one is mass. So the mass of the body, what is the mass? The mass of a body is the quantity of matter, that means the material which contained in it. So the mass is a scalar quantity. Scalar means which has only magnitude, that means it is 5 kilo, 1 kilo, but not the direction, that in north, east, west or south. Okay, so the mass of a body object is commonly measured by an equal arm balance. Okay, and SI unit, that is most important, it is written in short form kilogram. SI unit of mass is kilogram. Okay, and the weight, you know that earth attracts everything towards itself. Okay, towards its center. So the weight of the body is the force with which it attracted toward the center of the earth, that is called the weight. Okay, so we know that force is equal to mass into acceleration. So now here the force is equal to mass into acceleration, and that acceleration is due to the gravity, so that A is denoted as Z. Okay, so weight W is equal to into Z, you will find here. Now it's SI unit. You know, weight is measured in the same unit as force, and we know that SI unit of force is Newton. So SI unit of weight is also Newton, which is denoted by letter N, capital N. So how will you calculate it? So the weight is equal to m into g, m 1 kilogram, and the value of g is 9.8 meter per second. So its weight is equal to 9.8 into 1 kg into 1 meter per second. So now by definition of 1 kilogram into 1 meter per second is equal to the Newton. Okay, so this one is the equal to 9.8 Newton. Students, now spring balance, you are seeing that this is a device used for measuring the weight of the body, and a pointer and a long rod ending in the hook is fixed its lower end, you are seeing here. Okay, this one is its ending. Here you will hang the weight and you will find its load. Okay, and there is a metal ring on the top, its top position, and in case of hang it, and the scale marking shows here, you are seeing 1 kilo, 1, 2, 3, 4, these. Okay, and small marking are also there. So each small marking shows 100 grams. Okay, so a spring balance measures the weight of the body by opposing the force of gravity with the force of an object which is extended spring. Okay, next topic is principle of spring balance. So a spring balance works on the principle that when a body is hung on spring, so the extension here, the extension of the spring is proportional to the weight, and finally we will find the weight. This means that twice the weight stretches the spring twice far, and thrice the weight stretches the spring thrice far. Okay, so this effect was summed up by the British scientist, that's name was Robert Hooke, and is known as Hooke's law, so that it is called the Hooke's law. Okay, students, I think it is sufficient for today, and remaining portion of this chapter we will discuss in our next video. Till then, thank you everyone.